Log, exponent, and inverse functions in Algebra 2. So this portion has a good amount of information in it, but most of it is done in the calculator. The first part, we're talking about converting things from log form into exponent form. So I've given you in the first two boxes kind of the models on how we do this. So logs are written like this, with log base, the result, and they always equal the exponent. So if I want to take this log form, log base 5 of 125 is equal to 3, I need to convert that to an exponent form, which is up here. So first, I want to figure out what my base is. And my base of this is 5. 5 is what's going to have the exponent. So I have 5 as my base. Then I want to figure out what is my exponent going to be. Well, in log form, they always equal the exponent. So in this case, it equals 3, and that exponent is written up above my base. So I've got 5 exponent 3 equals my result. And my result is what's written next to the base, or it's what equals the exponent. So in this case, 5 to the third equals 125, which makes sense because 5 to the third does equal 125. And we can go the same way if we are going from exponent form into log form. So first I need to write the word log, and then notice here in this form the base is written smaller and kind of below log. So again, log base, well, the base of my exponent is 9. So log base 9, and then after the base we write the result. An exponent, the result is what it equals. So log base 9 of 1/3 equals, remember logs always equal the exponent, and in this case it's going to equal -1/2. So that's how we write them in different versions, converting the log to an exponent and then converting the exponent to a log. Now with solving is a little bit difficult because our brains don't compute log form, but luckily our calculator does it for us. So if we get our calculator, we're going to hit alpha, window, option 5, which is my log base. Now I can type in the bases that I need. So log base 3 of 27. And that equals 3. So we'll say x equals 3. Now with the exponent, 49 to some power is equals 7. So here, in order to put it in my calculator, I want to put it back as a log. So I'll say log, again my base is 49, my result was 7, and it equals my exponent of x. So now I can go alpha y equals 5, oh I'm sorry, alpha window 5, 49, 7. Enter, and we get 0.5. We don't like decimals, so we have to go math, enter, enter, and get 1/2. So for this one, x equals 1/2. And you can always take that 1/2 and plug it back in for the x to make sure you are right. Now the inverses, they get a little tricky. So the first step you want to remember about an inverse, and we talked about this in Unit 1, but our first step is we want to switch x and y. And then our second step is we want to solve for y. So for this first one, y equals log of 3x plus 4. Here's a side note you want to take, that whenever you see a log without a base, that really means log with a base of 10. So anytime you don't see that little number, it's really a base of 10. So my first step is I need to switch my x and y. So we're going to say x equals log, and remember that's now base 10, of 3y plus 4. Now in order to solve for y, we need to get rid of the log first. But we don't divide by log. That's not a thing. Think of what we just learned at the top when we converted a log form to an exponent form. That's what we need to do with the inverse. So we're going to take this x equals log base 10, 3y plus 4, and convert it. So again, my base is 10. Logs equal the exponent. So 10 to the x now equals 3y plus 4. Then from here, we can just solve. So we subtract 4. Now 10 to the x minus 4, they are not like terms, so we just keep it as 10 to the x minus 4 is equal to 3y. Divide everybody by 3. And since these two have the same denominator, we can just write it as 1. So we'll say 10 to the x minus 4 all over 3 is equal to y. And that's my inverse. Now, with graphing, it's the same situation. So first, I'm going to label my point A, and that is located at 1, 5. And I also have a vertical asymptote, which is x equals, and that occurs at -3. Now my inverse, and we say a to the 1, which we call a prime. Again, we switch our x and y, so it becomes 5, 1. Switch x and y. So instead of saying x equals -3, we're going to say y equals -3. So to plot my inverse, I'm going to use my lines and say y equals -3 gets a horizontal dashed line. And then I'm also going to plot my new point at 5, 1. And then I'm going to graph it. Now, how did I know it was supposed to go this way? If you think back to Algebra 1, you should remember that the line y equals x is a diagonal line through the origin. And if you were to fold this graph on this diagonal line, would your points and would your graphs match up? Yes. So that's how I can figure out it's supposed to go in that direction. Now, if we flip the page, we get back to something that we've done 2 or 3 units before, and this is all calculator. So the top just explains what this chart is about, and anytime we see a chart in our calculator, we want to go to Stat, Edit. So list 1, I'm going to put the top, which is 0, 2, 4, 6, 8, 10. And then in list 2, we put the bottom. And take your time because you don't want to mess up plugging these numbers in. Okay, we should have the same number of values in list 1 as we do in list 2. So, part A says write an exponential regression equation. And in order to do that, in our calculator, we hit Stat, we go over to Calc, and we're looking for exponential, which if we keep scrolling down to number 0, we see EXP REG, so exponential regression. So we want that. Then we go down to calculate, and here is our equation. The difference is here is we want to put B in parentheses. So we are going to say y equals 180.38 parentheses 0.95 for B, raised to the x power. So there is my regression equation. Now part B, use your model to estimate the temperature of tea after 15 minutes. So here's the key, 15 minutes. That is what x equals. So we're going to take that, y equals 180.38, parentheses 0.95. In this case, we're going to raise it to the 15th power. And read your directions, round to 1 decimal place on this one. And we can type that whole thing into our calculator. So 180.38, parentheses 0.95, caret button to the 15 power, and we get 83.6 is going to be our answer because that is 1 decimal place. So y equals 83.6. That should be a bit of review. We're just hitting a different button to get a different equation. Now part C is a little bit new, and I've given you directions in a box down here on how to figure out part C. Before we do anything, you have to turn your diagnostic on. So in your calculator, we're going to follow these steps. Hit the mode button, scroll until you see Stat Diagnostics, which is right here, and you want to turn that on. So we want to make sure the black box is highlighted over on. Once you have Stat Diagnostics turned on, hit second, quit. Now part C, is the exponential regression the curve of best fit? We go Stat, Calc, 0. We calculate this again. You should now see new letters, r squared and r. If it's the best fit, r squared is going to either be the number 1 or really, really close to 1. And when we write these out, we would like r squared to have at least 3 decimal places. So in this case, it's 0.988. So for this, we would say r squared equals 0.988. That's really close to 1, so we would say yes, it is a curve of best fit.